Hey there, this is our video on our periodic table of elements. In this video, we will be going over periodicity as well as the trends found in groups 2, group 7, and period 3. Let's begin. Now, before we get into any of those trends, first we must go over the structure of the periodic table so you can figure out why certain trends are the way they are in the different groups and periods. Currently, the periodic table has 118 elements. Now, all these elements are listed based on their increasing number. The periodic table itself is structured with rows and columns, the rows being periods and the columns being groups. Moving along a period, the number of protons and electrons in an element increases by 1. Remember, going down the period. All the elements in the periodic table are based off of two things. They can either be called a metal or a non-metal, and there are also the metalloids, which are elements in between that combine similar properties between metals and non-metals. Some important groups to remember for this video are Group 2, the alkaline earth metals, and Group 7, the halogens. Now, let's move on to electronic configuration. In electronic configuration, we use the groups and periods to determine the number of electrons and the number of shells in an element. So, for example, in periods, all the elements in the same period share the same number of shells in the atom, while all the elements in the same group have the same number of valence electrons in their outermost shell. So say for example we have period 1. Every period 1 element will have 1 shell, while every element, let's say in group 2, every group 2 element will have 2 electrons in their outermost shell. Another keynote in the term groups is that in group 0, every element has a full valence shell. So this is why that these elements tend to be unreactive with others, because they already have a full valence shell. The only reasons why elements react with other elements is so that they can lose electrons or gain electrons to gain a stable electronic configuration so that they can be balanced. Now let's talk about some important terms that you can use to describe the element's physical properties. You have ductile. Ductile means that the element can be shaped into a wire. Malleable means that the element can be hammered into any shape you want. Sonorous means that the element can produce a sound after being contacted with a force. Dull means that the element is not too shiny and it's actually not that great at sound emitting. Luster means that an element is shiny. And brittle means that the element breaks easily. Now, let's talk about the properties of metals, because metals make up almost all of the periodic table. It's almost impossible to go into a single group or period and not find a metal lying there. So metals are usually solid at room temperature, except for mercury, which is the only liquid metal that you can find on the periodic table. Metals tend to be highly dense. They're usually very sonorous, they're shiny, they're very malleable, and they're also very ductile as well. They are also exceptional conductors of heat and electricity, making them a very versatile, making most metals a versatile element to use mostly anywhere in the world, really.
Okay, so good morning class. Today we'll be learning about properties of non-metals. So the first property is that they are mainly gases, such as chlorine, argon, and neon, at room temperature, but some are solid, such as phosphorus and sulfur. But there's one exception, which is bromine, which is a liquid. Now, non-metals also have a low boiling point and a low melting point, which means that at a low temperature that they require a low temperature to either melt or boil. The other property is that they have low densities, which is kind of obvious in its own way. The next is that they are poor conductors of heat and electricity. So if you're doing an experiment or a project where you need a good conductor of heat and electricity, then a non-metal is not the correct conductor that you need. So I do not recommend using non-metals. So the next property is that when they are solid, they are dull and they are brittle. So if you were to have a non-metal as a solid, then they will be very dull, they will not be sharp, like a dull pencil, and they will be very brittle, so they're not soft, they're not smooth, those kind of things. And let's say you like drop a non-metal on like a surface, they make a dull sound. So if you dropped it, it would make a dull sound. Now on to the next slide. These are the general trends in the periodic table. So when you go down a group on a periodic table, you go down, the metallic nature increases. And when you also go down a group, the non-metallic nature decreases. So when you go down, you'll find more metals and less non-metals. But when you move along a longer period, which is left to right, the metallic nature decreases while the non-metallic nature increases. So when you go left to right on a period, you find more non-metals than metals. So here are some important terms you need to know. So the first one is atomic radii. This is when the radius of the atomic radius is 1/2 the distance between the nuclei of two atoms of the same element. So a good example of this would be cesium, which is the largest atomic radius at 298 pm. And the next term you need to know is electronegativity, which is the measure of the ability of an atom to attract electrons itself. Another example of electronegativity is fluorine, which is the most electronegative element. More important terms you need to know is ease of ionization and ionization energy. We'll get more into these into the next slide, but these are just basic definitions for this. So the ease of ionization is the ease at which an atom loses or gains valence electrons. And ionization energy is the amount of energy needed to pull an electron away from an atom in a gaseous state, or the tendency of an atom to give up its electrons. There are 3 types of ionization energies, the first, second, and third. Now, either ionization, like I said, we'll be getting more into this. Metals tend to lose valence electrons. These were positively charged ions known as cations. And then non-metals tend to gain valence electrons. These were negatively charged ions, which are known as anions. Anions are electrically charged particles that are formed when an atom loses against an electron. So that is basically what ease of ionization is. It's very simple if you know the basic consensus for it, and that's basically it for my side. Then we'll be going to the next part.
Alright, so now that we've covered basically everything you need to know about the periodic table, here are all the trends that you can find in groups 2, group 7, and period 3. Let's begin with group 2.
Everyone, tonight I will be telling you guys about group 2 trends. Sorry for a long entrance. Alright, so group 2 trends consists of beryllium, magnesium, calcium, strontium, and barium. Also, I don't know what radium is doing here. I think it's there. I don't know. I have no idea actually, but I'm going by what my chemistry teacher showed me. Alright, so now I already explained to you what group 2 trends consists of. So now so for group 2 trends, their melting point increases for all of them except magnesium. While going up the group. So while we're going up, their melting point increases except magnesium. Y'all better listen, because if y'all fail, it ain't my business. So now, these are fairly soft metals. So they're like what? They're shiny and silver. Well, shiny like the teeth, but they're shiny and silver, like this. They're shiny and silver, or they just look, eye-catching, and they turn dull quickly due to reactivity. This is due to a dull oxide layer being formed, and they have fairly high melting points, and they only carry 2 valence electrons. Two. So we have beryllium with 2, magnesium with 2, calcium with 2, strontium with 2, barium with 2, and radium with 2. Okay? Metal cations have a charge of 2+. Their cations cations are positive. Cations, positive. They have a positive charge of 2 plus, not anions. Anions are negative. Cations are positive. They have a charge of 2 plus. Dos, whatever plus is in Spanish. Okay. So now atomic radii increases going down the group. This makes it easier to lose valence electrons. So while going down the groups, going down from beryllium all the way down to radium, they will lose valence electrons. So while the atomic radii increases going down the group, this makes it easier for them to lose their valence electrons. Thus, when it comes to grouping them, their valence electrons will be given up because of that. Alright, because I'm using the social department, so I have to read off of this. So now, valence shells become more shielded. Right? They become more shielded from positive nucleus by internal shell. Ease of ionization increases going down the group again. The ease of ionization increases while going down the group. They increase while going down the group. So I mean they decrease while going down. If that makes sense. So now, reactivity with oxygen / water or water and dilute hydrochloric and sulfuric acid increases going down the group. So again, reactivity with oxygen or water and dilute hydrochloric and sulfuric acid increases going down the group. So the reactivity with these products and elements increases going down the group. So radium would have stronger. But mention radium as just when it went up to barium. So barium has a higher reactivity with oxygen and water, and also dilute hydrochloric acid and sulfuric acid. So because of reactivity, an element is displaced from its compounds by an element below it within a group. I don't know what that means, but we're going to continue. This is known as a displacement reaction, which occurs when an element in its free state takes the place of another element in a compound. A more reactive will displace a less reactive element from a compound. So I just made sense just now. So again, let's say for example we have magnesium, which is a solid, plus beryllium. Well, beryllium chloride, which is an aqueous, then gives us magnesium chloride plus beryllium, which is also a solid when it was thinking. The reason for this is because magnesium is more reactive than beryllium. Oh my god, why did you see my message? You can say this, you know? Alright, so magnesium is more reactive than beryllium because again, see. Magnesium is up here, beryllium is up here. Magnesium is here, beryllium is up here. So remember, going down the group, they become more reactive with stuff like hydrochloric acid. And remember, chlorine helps to make hydrochloric acid. So give or take. So it has a higher reactivity than beryllium. So magnesium will then take the place of beryllium, making magnesium chloride plus beryllium. ¿Entiende? ¿No entiende? I don't care. So this is known as a single displacement reaction. there, let's see, for example, we have iron, okay? Iron. Iron has a high reactiveness. And for example, they give us copper 2 sulfate. And copper has a charge of 2 plus, or so I think. And again, iron has a high reactivity than copper. So iron does now take the place of copper, which now makes it iron sulfate plus copper. Alright, so let's focus on their reactivities is high.
Alright, now moving on to the wonderful Group 7 of the periodic table. Now, what is Group 7? Group 7, also known as the halogens, are all diatomic elements. Now, what does this mean? Diatomic elements are basically elements which consist of 2 atoms, as the name would suggest, as di means 2. Now, this group consists of the elements fluorine, chlorine, bromine, iodine, and astatine. Now, moving up the group, the strength as an oxidizing agent increases due to their nearly full valence shell, which consists of 7 electrons. Now, this means that elements at the top of the group, such as fluorine, would be better oxidizing agents compared to elements lower in the group, such as astatine. Now, let's not forget about the most important part, the state of matter that each of these elements are in. Now, going up the group, elements are more in a gaseous state, so elements such as fluorine and chlorine are gases. Going a little bit further down, we have elements such as bromine, which are usually liquids. And then at the very bottom of the group, we have elements such as astatine, which we all know are solids. And that is the conclusion of Group 7 and its strength.
We'll be moving on from Group 7 to Period 3. Pop quiz! What's the 30th element? That's right. Sodium! So, Period 3 consists of sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and chlorine. And also argon. Going from left to right, the non-metallic nature increases. Well, elements to the left side are metals. But one of them is a metalloid. Do you know which one? Silicon. Elements to the right are non-metals. Silicon is the second most abundant element on Earth. It can be found in Earth's crust and is a really good semiconductor. Each element in Period 3 has a valence electron in the same electron shell. Well, shell number 3. Moving along the period, there is one more electron and one more proton than the next. This is because there is a greater positive charge of the nucleus. The attraction between the positive nucleus and the valence electrons are greater. The atomic radii also becomes smaller due to increasing number of positive protons in the nucleus. Do you know what a nucleus is like? Usually, it's a bunch of atoms right here, surrounded by this shell. This shell contains the electrons and that orbits it. As we move along the period, it's going to get more stronger, and as a result, more electrons are going to orbit here. Because of the same concept, electronegativity also increases along period 3. But the ease of ionization of sodium, magnesium, and aluminum specifically decrease, while the ease of ionization of phosphorus, sulfur, and chlorine increase along the period. Argon is a nonmetal found in the right of chlorine. However, because it contains 8 electrons, it has a stable configuration and is chemically unreactive. Now let's go over some characteristics of silicon. Silicon is found in group 4 with 4 valence electrons. As a metalloid, it has a combination of metallic and non-metallic properties. It has 4 valence electrons. And by sharing these with other non-metals, that means it does not usually ionize. Thank you for watching our video.
We hope you have a better understanding now about periodicity, the trends of groups 2, 7, and period 3. Thanks for watching.